Hello, thank you for everyone for your time and especially our host. I am very happy to be here in the World Summit Artificial Intelligence 2022, face to face with all the community. Full autonomous flight is one of the greatest ambitions in aerospace industry. As other industries, we want to automate our main functions of our systems. So my name, as Alex said, is Miguel Martin Acosta, Chief Engineering Airbus UAS, and welcome to full AI-driven, full autonomous flight, the nuts and bolts. The first question when we are talking about a full autonomous flight is what is autonomous flight? We can consider an autopilot or fly-by-wire system, probably you know, are autonomous flight, but it's much more than this. If we think in a formal definition, we can observe that full autonomous flight is much more than this. With this formal definition, flight capability of an aerial machine without human intervention. Of course, we can consider that flight physics is important, what most of us probably think of guidance, navigation, and control is key for autonomous flight. But by this definition, it's not only that thing, because we cannot remove the human only with guidance, control, and navigation. And this technological gap that is key is only driven by artificial intelligence. If we want to have full autonomous flight, we need to trust on artificial intelligence and machine learning. Of course, if we think in the first thing, what is full autonomous flight, the second question is why we want autonomous flight. First, we want to automate, as another industries, in order to reduce cost, our systems. And the flight capability, the autonomous flight capability, is the most important thing in an aircraft. Apart from that, the aerospace industry is developing a new series of concepts and vehicles, probably you know, like flying car, flying taxi, UAVs, cargo drones, that are intrinsically linked to full autonomous flight. And this is very important because without the capability of full autonomous flight, we are not capable to deliver these solutions. So, as we discussed earlier, autonomous flight is much more than flight physics or guidance, control, and navigation. There are a lot of functions that we need to include in our system in order to really be capable to have autonomous flight. If we go to the definition, flight capability of an aerial machine without human intervention, what we need is to provide to our vehicle with the capability to fly without a human. First point, perception. We need to have the capability to perceive things. A system with situational awareness. This is key because the humans are capable to perceive our environment. So in some part of the flight, we need really to have the capability to perceive something. For example, during the landing, where the instrumental navigation is not accurate enough to perform that action. Or if we have terrain obstacles or mobile obstacles, as for example in urban flight. And for that, the perception is key. If we are capable to provide perception to our system, we will be capable to provide sense and avoid, sense and navigate functions that are key for full autonomous flight. The second one is connectivity, because we need to have a system connected to the world. The same way as an airplane connects the pilot to the world through the radio or other communication system, we need to provide our vehicle with the connectivity in order to get relevant information, for example, for a contingency, for a new flight plan, or for wherever we need to transmit or receive in our vehicle. Other important point that is typical in a human is the decision making. We need to have a system that is capable of doing the right thing in every time. The information is the fuel that provides all the data that we need to make decision, but the system needs to be capable to make this decision. Because, for example, we need to be capable to make a decision in order to ensure the operational flight, or above all, be capable to ensure flight safety. Health management, because we need a system capable to manage their failure and their issues. When you have a problem in an aircraft, there are specific procedures that need to be applied in order to ensure that we are going to get the right safety levels to avoid an accident. Our vehicle needs to have the same capability. Needs to have the capability to monitor itself, to diagnose the problem, and to take a specific solution. That this is key, because if not, we are going to have an accident. Integrated in the airspace, in the US space, this function is basic because we are not the only thing that is flying over the sky. So we need to be integrated in the airspace. At the same way that a manned aircraft is integrating to the airspace through air traffic management, we need to be integrated in our full autonomous system using a manned traffic management system. And finally, but not least, trustworthiness. I need to have a system safe, a system reliable, a system assured, a system explainable. This is basic. Because if we are not be capable to demonstrate that our autonomous system at least have the same safety level as non-autonomous system, we are dead. And this is one of the key points right now, because as I told at the very beginning, artificial intelligence, and specifically machine learning, is one of the fundamentals of the full autonomous flight. And when we have right now a specific problem with hardware and software in aircraft that are very complex, if we add an additional technology like machine learning, we need to face a very big challenge. And this is one of our very big challenges right now in the aerospace industry. How to implement machine learning in a certified environment. So in order to understand that, we are going to dig a little deeper in this point, because AI-driven full autonomous flight is basic. First thing to understand is the concept of artificial intelligence in the space environment. Because when we are talking about artificial intelligence for certification, we are not considering traditional techniques as, for example, persistence, or, for example, control engineering. Declarative techniques for artificial intelligence or symbolic AI is not under this scope, because the problem is understand the taxonomy using, for example, this simplified roadmap from EASA Artificial Intelligence Certification Roadmap. We need to understand what is our problem. And our problem is not the traditional programming, because it's persistent, control engineering, even if it's considered artificial intelligence, that it is not the problem, because we can consider that it's a traditional programming, and using our current software standards for development, we can have a set of tools in order to certify that kind of system. So the problem is when we call about machine learning. Probably the most of the people right now relate directly artificial intelligence and machine learning. And this is the problem, because machine learning is completely different paradigm. A system that is learning from data without being explicitly programmed for that. From our space industry, it's crazy, because it really pushed the very pillars of the certification in aerospace. That is completely different, because in aerospace, we are not only certifying the results of the product. We are certifying the processes. And when we have black boxes, like in machine learning, it's completely crazy to really be capable to justify from our authority how you get that. So for that, EASA has developed a roadmap together with industry. EASA is the European Aviation Safety Agency. And in this roadmap, what we have right now is a phased development of the artificial intelligence, machine learning framework in order to be capable to certify this system. So EASA, in this different phase, right now we are in the exploration phase, is delivering a set of tools to start our machine learning-based certification project. As you can see, we are right now in the exploration phase, but we will develop new tools, new frameworks, new guides in order to advance in different stages of this path. And obviously, we have defined different levels of autonomy. For example, if we are basing our main classical autonomy levels, EASA has more or less the same for machine learning. Really, I have 3 levels, but with 5 categories in total. So you can correlate directly autonomy levels from classical robotics or UAVs directly to that. And here is the problem. The level 3 is what we need in order to get full autonomous flight. And as you see before, we don't have an expected guide for level 3 up to 2024. So right now, full autonomous flight is the spearhead of the innovation on certification for autonomous systems. We don't have a guide, but we are working very hard with the authorities in order to develop this framework for the future, in order to be capable in 2035 to have even large aircraft with autonomous flight capability. But right now we have 3 concepts regarding aviation trustworthiness that right now we can apply and that are changing our way of understanding the certification of the machine learning system in aerospace. The first is learning assurance. One of the most important, because we need really to trust in our learning process in the same way that we trust in the process of development process of a software. And this is critical. We need to have data that is complete, accurate, adequate, enough quality, and we need to be capable to validate and verify that with independence. The one who is training the algorithms cannot verify or cannot validate because we need independence. Other important point is explainability of artificial intelligence. Explainability is a trend in not only in aerospace industry, but there is a misunderstanding. Some people think if I have explainable AI, it's certifiable. Nothing further from the reality. As you can see, there are another all question that we need to solve before we can say this is a certifiable system. And finally, but not least, artificial intelligence safety risk mitigation. We need to be pragmatic sometimes. And with the current state of the art, it's impossible that we are able to certify everything. We cannot open all the artificial intelligence black boxes. We cannot get detailed learning assurance process with the right safety level. So we need to combine our artificial intelligence or machine learning system with other mitigation means. For example, output control, threshold or limitation to the artificial intelligence actions, hybrid system that combine traditional techniques with artificial intelligence. And if we apply everything of this, then we can have an artificial intelligence-driven system for full autonomous flight that is capable to be certified. So there is a challenging path in front of us. It's totally clear. But we are advancing day by day in the aerospace industry in order to really be capable in the future to have the capability of full autonomous flight. But we must demonstrate that having hundreds of thousands of airplanes flying over our heads is safe, and only this confidence will allow the resounding success of autonomous flight. Thank you very much.
Thank you, Miguel. It's an interesting idea. You're not going to really know 100% what that AI is doing inside the plane, but you might want to fly on it anyway. So if we get to that point, I think you might have something on your hands. All right, let's take some questions from the audience. If we have mics here, just raise your hand and we will put it to Miguel. Okay, all right, we got one here. All right, we have the ice broken. Thank you very much.
So I wonder, so the full of autonomous flights, to me, it looks a bit far away, and you explain the reasons. But I wonder what would be if there is any intermediate, like semi-autonomous, anything that is realistically achievable in the near future.
Okay. The first response should be, we are right now applying semi-autonomous system, for example, autopilot. But if we focus on machine learning, yes, it's going to be an incrementally path. For example, the first idea is to have UAVs without passenger flying completely autonomous. We are going to test that technology because an UAV has safety levels, but not the same because we don't have passengers. Okay, if a UAV of 1,000 kilograms is crash on a building, there is a problem, but it's different problem. So we probably will start for full autonomous system, but with decreased safety levels. Because from technological point of view, we have already achieved some of the capabilities that we need. The problem mainly is the certification of that.
Okay, cool. We have another one over here, actually two back to back, so we'll let the mic runner make the decision. But you know, it makes me think, what happened to those Amazon drones, right? They were a nice 60 minutes piece, but doesn't look like they're happening. Speaking about, you know, autonomous flight that might not involve humans. Okay, let's go over here.
I know it's early stage, but are you taking a purely computer vision approach, or are you doing something kind of multimodal approach with radar and LiDAR as well in autonomous flight, or you know, are you just going to try to do what Tesla did, where they just went strictly to computer vision?
Right now, it's a hybrid approach. Obviously, there's something that right now it's working very well. That's navigation using instruments. We are not changing that. When we are on the ocean, we are going to navigate using instrument, mainly GNC. But what we are going to perform in order to increase safety levels is to combine different kind of sensors, for example, LiDAR, computer vision, radars, new technologies. For example, we use GPS positioning and 5G positioning in order to get the position. So it's a full, complete set of sensors that we are going to fuse in order to have a more accurate situational awareness.
Okay, great. We're at a minute 35, so let's see if we can get a 20-second question and a 1-minute answer. All right, go ahead.
Just a quick one. I wonder what sort of cybersecurity implications there are to this. I wonder whether we're going to end up with like a remote situation of 9/11, but where someone's just controlling the plane from the other side of the world. Is that part of the process in the certification?
But secure or safe?
Cybersecurity, like what prevents somebody from hacking and just taking remote control?
Okay. It's something that is a problem. Usually this airplane system can different technology than the commercial one. We are not using Windows or Linux. We are using certifiable operating system that are much more protected. And we have a specific, it's another issue, but we have a specific certification with the right or the same level of robustness as the safe. Because the security can affect the safety. So we are focusing too on that, using mainly certified security systems.
It's a great question. By the way, thanks for these questions that have been questions on topic and not speeches. More of those, please. It also reminds me a little bit of someone hacked the taxi system in Russia, and you saw all those taxis going to the same intersection and causing terrible traffic. So, but I hope we don't have that with planes.
I didn't know, but probably the taxi were using Windows or Linux. So.
Okay, all right. So you guys get working on something that won't have that issue. Everybody, give it up to Miguel. Thank you so much, Miguel.
Thank you.